All right. Hello, everyone. Hello. Hello. If you came in later, I apologize that you didn't see my funny slide. If you did take a photo of that and decide to tweet it, please CC at @dcampbell so that I can see how it goes viral, right? But thank you for paying attention to that and sitting up close because, yes, I don't expect a full room. And I find that this sort of talk does much better when we're not spread all out amongst a wider room. So as long as I can see some smiling faces, thank you for smiling at the right moment, then we can have a good talk. Just to have a kind of a level set about this talk, how many here would consider themselves to be professional F# developers that have code in production? There's one, two, okay, a couple of you. Excellent. That number is increasing. Every time I've given this talk, there have been more hands that go up, which is excellent, right? That's a good sign. How many have personal projects in F# or have done some tutorials or just the hello world or that sort of thing? Okay, fair number of people. And then how many of you would say that you're just curious about F#, that maybe your team back home saying, hey, I want to do F#, and you came out here to see what it's about, that sort of thing? Okay, that's the majority of you. And so this is kind of a difficulty with giving this talk is that I have to speak to these various levels, and I will try and do my best to do that. So we'll try and have something here for everyone, all right? Now my name, as you see up there, is Dustin Campbell. I'm a senior program manager on the Managed Languages team. Chiefly, I'm responsible for the editing experience in C# and Visual Basic. So things like IntelliSense and all of that, that's what I'm accountable for. For the past 3.5 years, I have worked on a project called Roslyn, which is a rebuilding of the C# and Visual Basic compilers and IDE experiences for the future. And these days, I kind of work on the present and the future, okay, with regards to C# and Visual Basic. But that should send some warning bells clanging in your head. Why is the C# and VB guy up here talking about F#? Right? You should all be a little bit concerned right now that there's some rogue that's come in that, he's going to try and talk to you about F#, but he really doesn't know much about it. That's not really true. The reason I am standing up here is because I am an F# fanboy. I absolutely love this language. I love how it allows me to write elegant code. Very simple, elegant code. And so a lot of my personal projects, if you were to look up Dustin Campbell on GitHub, you would find most of my repos, both public and private, if I allowed you to see them, are in F#. In fact, when I joined Microsoft 5 years ago, I was interviewing for an F# developer position that I did not get. I interviewed with the team, and the interview didn't go as well as I would have liked. Those things happen. But they actually shifted gears in the middle of the interview loop and shifted me over to a program manager loop. And so I started interviewing for that role, and I got that, right? And so I was a C# MVP at the time, interviewing for an F# developer position, and I wound up getting the job of the VB IDE program manager who delivered the VB IDE experience for Visual Studio 2010. Okay, so I'm kind of a language guy. I really like languages. I really like tooling around languages. And so, as someone who loves languages, F# speaks to me, okay? And that's why I'm here to talk to you. And I want to point out, I'm not the only one, okay? So these are some testimonials from people that have used F#, and they're gushing. If you go to if you go to fsharp.org, you will find a whole list of testimonials on the F# Foundation website like these. My favorite one is there at the very end, where it says, F# encourages reason-driven development that leads to virtually bug-free code. Okay, and that's very much my feeling as well. All right, so that one also really speaks to me. Okay, so our agenda. Now, as I said, we'll try and have something for everyone. We'll try and go from kind of the basics of the language and what it is and how it came to be, especially for those that are curious and trying to find out what this is. For those of you that have played around with it or just sort of dabbled, we'll do a bit of a primer. And that's because F# tends to have a very different syntax from what we're normally used to in our curly brace languages. It's good to kind of have a language primer so we can kind of have an even playing field. All right, so we'll do some of that. And then we're going to talk about F# 3.0 features that were designed specifically to solve a real-world problem around big data. And that's very, very new, and I want to talk about that to some extent at the very end. Now, let's just kind of dive right in. What is F#? And this statement is true. F# is a practical, functional first language that lets you write simple code to solve complex problems. And boy, are there a lot of loaded phrases in there, right? Let me unpack a couple of those for you. So, what does functional first mean? Well, how many here are familiar with the notion of functional programming? Okay, fair number of you. F# is, at its core, a functional programming language. We like to say it's functional first because you can write in more styles than just functional programming in F#. You can write object-oriented programming. You can write an imperative programming style, the style that most of us are comfortable with. But F# really leans towards a functional style of programming, and it encourages you to program that style and offers many features that are baked very deeply into the heart of the language that really target a functional programming style. Okay? In a similar vein, on the other side, C# or Visual Basic, they are not functional first languages. I would think of them as object-oriented first languages, where they really tend to lean you towards the idea of, class hierarchies and inheritance and implementation of interfaces, and those sorts of concepts, right? Polymorphism. They do have features that allow you to write in a functional style, however, right? Since C# 3.0, we've been introducing features like lambda expressions to make it easier to write in a functional style. But that's not its first love. So simple code. Now this one is interesting because that means a lot of things to a lot of people. And so I want to give you a little bit of a crisper definition of what I mean by that. Simple code means elegant code that's understandable code and maps very closely to the problem domain that it solves. Okay? So something that maps very closely in an elegant way. That's the idea behind simple code with F#. And then one other point I want to make about complex problems, because it kind of implies that you only use F# to solve complex things. Like, okay, I've got the big complicated algorithm, time to pull F# out of my back pocket and do that and solve it. And that's not the case. The reality is that F# is very good at solving any problem with simple code. Okay? It's just that it also lets you solve complicated problems with simple code. Okay? So you can solve any problem, simple ones, complicated, but all with simple code. Now, just a brief history of where F# came to be. F#'s actually been around for a while, for about a half a decade, actually longer, about 8 years. F# 1.0 was a Microsoft research project introduced in 2005. It showed up on Don Simon's blog in 2005. And he kind of dropped it out there, and it started to gain traction. Okay? And over the next couple of years, it really started to gain traction in financial industries, industries where there was statistical analysis and computation. And these companies were using F#, and they really wanted to use it in production, but they wanted to have, I guess, more of confidence in the support of the language rather than just being a research language, which, we could abandon it at any point, really. And so we chose to productize the language as Visual F#, and that happened in Visual Studio 2010. So in March of 2010, when we released Visual Studio 2010, with F# 2.0, that is when Visual F# was productized as a real Microsoft language with full support, with full IDE integration and all of that. And so then people could go ahead and use the language with confidence, right, knowing that it's got the full backing of Microsoft behind it. This past August, we released a new version of Visual Studio. It seems like forever ago to me, by the way, August, because it seems like we've been working on that version. We'd worked on it for a couple of years. But to you guys, it's probably still pretty fresh, right? I mean, it's only 10 months ago that we released this version. And that included Visual F# 3.0, the next iteration of the language. And so that's kind of a brief history. It started in 2005, and we productized in 2010, and we're continuing to iterate and build on it. Now, a little bit more about F#. F# is a 100% .NET language that targets the CLR, okay? Just like C# and Visual Basic. And that comes with some very important qualities, very important advantages. The first of which is that it can operate with other .NET languages, right? So it can consume any .NET library or framework. So anything that you have that you use in C# or VB, you can use in F#. All right? And then it can be consumed by other .NET languages. So if I build libraries with F#, they can be consumed from C# or Visual Basic. The important point here, and the reason that that's really important, is because it allows you to use the right tool for the job. Often I will find myself writing an application, and one of the demos later will show this, writing an application where F# is used at the core for business logic, for analysis, for computation, for data transformation, things that it really excels at, where it maps very closely to that problem domain. Right? So using the F# as the right tool for that job. And then maybe my application, my UI, is written in a different language that lends itself much better to UI. And maybe my unit tests are written in yet a different language. And so I really strongly adhere to this idea of kind of using the right language, the right tool for the job. You can write your entire application in F#. It's totally possible. It's complete .NET language. But I really like to push this idea of using the right tool for the job. And we'll see some of that later. And then another point about F#, and this is one of the things that people truly love about the language, because it uses strong typing to prevent bugs. That earlier quote that I showed about that F# encourages reason-driven development, where you write code that is bug-free. The reason that happens, that people feel that happens, is because F# catches so much when you're writing your program. So many bugs that other languages would leave for runtime, F# will find at design time and compile time. So, for example, in F# 1.0, a feature was there that I thought was super cool. It is super cool. But that, for printf style format strings, so where you have like %d and %s and those sorts of things, where you're actually declaring the types and how they should be formatted within the string, it would do type checking on the arguments passed in. So if you had %d and you passed a string in, that would get a squiggle and it wouldn't compile. Right? So it actually had type checking on those format strings, something that would happen at runtime in a language like C# with string.format. In F# 2.0, a feature was added called units of measure. And units of measure add type annotations to floating point values in your code. So you can create little mini type systems around floating point numbers. So things like weights and measures like kilograms and meters per second squared. You can also provide conversions between them that actually affect the units that is carried along with those floating point values. You can imagine, having dollars and euros and all those sorts of things encoded in the type system in your code, and so that F# can then, in the type checker, the F# compiler will squiggle and add errors and find things at compile time. You could sort of do that today. You could do that with C#. But you would write a lot of boilerplate. You could create a struct called dollars and has a value inside of it, and a struct called euros, and provide conversion routines and implicit conversions, and you would write a lot of code to do that. And F# has it baked in. It's pretty cool. And then finally, in F# 3.0, F# 3.0 takes static typing another level, allowing you to introduce static types into the type system dynamically. Okay? So as opposed to having the feature dynamic like C# has, where things resolve at runtime, they still resolve at design and compile time, but static types are introduced dynamically. And so we use this for adding type checking for data schema, right? So I can get static validation type checking when I access schema. And we'll look more at that later. Okay. Simplicity. I talked about simple code. I talked about elegance, mapping to a problem domain. And so I just want to give an example. Okay? We're going to contrast C# and F# a little bit. So this is some C# code. And I get that it might take a little bit to parse. Some of you might not even be as familiar with C# to see that. It's pretty gnarly, actually, a little bit. I've looked at enough generic code in my day that I get it. That's fine. I mean, these are functions that operate on tuples. The first one takes a tuple of t and u and swaps the items in it, right? So it takes the first item, the second item, and it returns a tuple with the second item and the first item, right? Just swaps it. The second one performs rotations on a tuple of 3 elements and returns a sequence of all the rotations. And the last one takes a function and a 3-element tuple and returns the result of summing the applications of that function to every element of the tuple, right? But the generics look kind of crazy to me. Especially when you get to the return type of rotations, where it's IEnumerable of tuple of t, 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 and then 2 right angle brackets. And whenever I type those, I feel like I'm somewhere in the world, like somebody's just really had, stepped in a mud puddle or something because of what I just did, right? That my karma has poorly affected the world. And it just creates readability problems, right? And another problem with this is the tuple type itself, which was introduced in .NET Framework 4.0 to support F#. It has these properties on it, item 1, item 2, item 3. And you lose semantic information when you use a tuple class. There's meaningful data that we would pack into a tuple, but you don't know what it is, right? You put a tuple, you say, maybe I put first name, last name, customer ID, salary, but I'm accessing it with item 1, item 2, item 3, item 4. And my code becomes less readable, right? And so that's another problem on the C# side. So I said we'd contrast it. And I'm going to give you, this is the F# version of this. And this is functionally equivalent. This really produces pretty much the same thing. But it's much cleaner, isn't it? One way to look at this is to look at it as the C# code with all of the extraneous stuff tucked away, kind of hidden away. The types are there. The tuples are there. But F# makes it much cleaner. So what you're seeing here is let's take a look at swap. Swap, again, it's defining a function using let. Let binds names to values. This is the idea behind that keyword. And we're defining a function swap that takes a tuple, that's the parentheses with the comma, with 2 elements, x and y, and it returns a tuple with y and x, right? That function is actually just as generic as the one on the C# side. F# has a very rich type inference system, much richer than, say, C# var. How many people use C# var? How many people really dislike C# var? Okay, there's always a couple, right? F# takes that sort of type inference to kind of a whole other dimension. It will in fact infer the very signatures of your methods, getting parameters and return types, but it will also automatically generalize functions for you. So in this case, it doesn't know anything about the types that go in the tuple, so it adds type parameters under the hood. And so that is a tuple that takes generic type parameters 1 and 2 and returns a tuple with generic type parameters 2 and 1. Okay? Similar like rotations, it's very clean to look at that and see that it returns a sequence that yields these 3 different tuples. And it's much easier to read than the one on the C# side, where I have to look all the way to the end of the item property to figure out which one it is, right? And then the one I really like is the very last one, where there's a function f, but it never said it was a function. The only reason it knows it's a function because of how it's applied. And that particular routine I like a lot because it maps very closely to a mathematical domain, where F# really, really excels. All right, so let's take a look at some code. I'll get out of slides here. Let's look at some code not in slides. All right, so this is tryfsharp.org. How many people have checked out tryfsharp.org? A couple of people. This is a very cool site. It's very professionally done. It has pictures of very studious, intelligent-looking people on it that should immediately tell us that this is a place we want to go because we want to be with those intelligent people, right? Especially this guy. So this website is filled with information on a learning F#. We can use it to, in a web editor, actually write some F# code and play around with the language. Let me just give you a flavor of some of the things you can do here. We'll go to the data visualization and charting. And assuming the internet doesn't fail me, everything will work well. So let's just go to the charting quick start. All right? And you see that there's a bunch of information here talking about the feature and talking about what F# is capable of. Over here is actually an editor, a code editor in the browser. And down here is essentially where the results will be evaluated. Okay? So I'm going to go ahead and load and run a couple of these. Okay, and so it just included a namespace. And this one is going to chart some lines. Right? So this is a very cool way to start exploring F#. So we can continue on, do some very cool stuff with labeling the y and x axes, combine two charts together. You could do stack charts. There's all sorts of cool things. And so this is just kind of flavor of you can go to this site and read about F#, and if you're interested in the language, really learn a lot about it, learn how it's useful, learn the domains that it's very, very good at. But let's go over to create. And I just want to kind of get started with just a little bit of syntax. We're starting to kind of get into the syntax primer portion of the talk, where we want to make sure we're on some even footing with regards to the syntax of the language. So this in particular, and can everybody see that? Or should I zoom in a little bit? Let me give you a little bit. I just like to do this on my mouse pad. It makes me feel cool. All right. There we go. All right. So this is just a list. It's a core data type to F#. This is a list from 1 to 20, exactly what it looks like. Okay? And when I evaluate this, when I run it down here, you see that indeed it is a list that produces the results from 1 to 20. Okay? Now, F# provides for manipulating lists. A big focus of F# is really on data transformation. So taking core data types like lists and trees and being able to transform those. And so we're going to use a couple of combinators functions to transform this list. And so the first one I want to use is, let's just filter the list. Think about C#link, where you would do like, from X in this enumerable with range 1 to 20, where X mod 2 equals 0. So we would get back the even numbers, right? And so the idea of the where clause in C#, in F# the analog is list.filter. So I'm going to type list here. And again, this is a web browser editor, so you're going to see the full IntelliSense that you would see in the IDE. And so I'm going to call list.filter, and I'm going to pass in a lambda expression, an F# lambda expression. Now, F# uses the keyword fun here, just as a reminder, right, that this is indeed a lot of fun. Right? And we're going to do exactly that. We're just going to return the even numbers. So I'm going to filter the list down and return a list for which of the elements for which this predicate returns true. Okay? And so we'll run that. And indeed, down here, we get the even numbers. Okay? Pretty trivial. Now, F# provides a pipe operator, which is useful because my list is all the way over to the right. If this was a longer function, it would be hard to read, right? And so F# has a pipe operator similar to something you would find in a command shell, like a Unix command prompt or a PowerShell. So I can take that value and pipe it in from the left using the pipe operator. Okay. I run that, and again, we get the same result. So everything's still working. Now, let's do another one. Because the great thing about the pipe operator is that I can take the result from that and continue to pipe it into more functions, into more combinators. So I'm going to use list.map. List.map is similar to, again, taking the analog back to C#link, if you're familiar with that. It's similar to select. It's a transformation function that takes a list and a transformation kind of function and applies that transformation function to every element in the list and returns a new list of those transformed elements. Okay, so what we're going to do is so the function we're going to pass in is going to take, it's going to take x, and it's going to return to us a tuple of x and its square. Okay, so you saw that tuple syntax previously. That's what it looks like here. So let's go ahead and run that. And again, down here we get the result. So at this point, you should believe that we can use F# to write toys. Right? We can just write toy code in F#. And so I want to get away from this. This is just starting to get us into some syntax, and I kind of want to go to a different problem. All right? And the problem I want to look at comes from a website called Project Euler. How many people have heard of projecteuler.net? Cool, cool. I love this website. I think of it as a fitness website for programmers. Project Euler is a series of math problems that start very easy. They're very easy to solve and very quickly, around like problem 20, they become very difficult, where you have to, know some number theory tricks because the problems start to become very hard to compute in a brute force sort of way, right? Some of which would take millennia to solve if you brute force them, right? And so it's very fun to try and come up with some clever solutions to some of these problems. And also, I'm gonna be honest with you guys because we're all friends, right? So my wife and I have occasionally done Project Euler problems on date night. And that's not weird at all, okay? We're cool. It's very fun for us because my wife doesn't know F sharp, right? I know F sharp. My wife doesn't know F sharp, but she is mathematically inclined, and she does enjoy solving math problems, right? And the language itself is so simple in solving some of these Project Euler problems that it's immediately obvious to her what the solution is and how we write that code. Because we're almost simply writing the math problems themselves in a language that's very similar to that domain. And she's able to spot bugs when I'm writing the code. Right? So it's kind of a cool testimonial from my wife about F sharp, and that she would prefer that her husband do different things on date night. Okay, so you've probably been trying to read this while I was talking, and I'll read it to you because it is a little bit small. But Project Euler problem number 6 is the sum of the squares of the first 10 natural numbers is 1 squared plus 2 squared all the way up to 10 squared, and that equals 385. The square of the sum of the first 10 natural numbers is 1 plus 2 plus, all the way up to 10. Square that, and the result is 3,025. Hence, the difference between the sum of the squares of the first 10 natural numbers and the square of the sum is 3,025 minus 385, which equals 2,640. Find the difference between the sum of the squares of the first 100 natural numbers and the square of the sum. And so this is actually a very simple problem. The problem is actually in the text and trying to figure out what they actually mean with all the squares and sums and everything, right? But we can just simply write it down. And the great thing about this is that they gave us a unit test, right? They said, well, if you do the first 10 natural numbers, you're going to get 2,640, right? So let's write that and see if we get that. Just writing simple code, using code that is very similar to what we just were using in the tryfsharp.org. So I'm going to write list sum. We're going to sum 10 natural numbers, and then we're going to square that. Square those two. Okay. From that, I'm going to subtract list.sum, where I've taken the 10 natural numbers and I've squared them all. So I'm going to use map here to square them. So we're going to pass in an anonymous function that squares elements, pass in our 1 to 10, and there we go. That's all we need. Now I'm going to evaluate this with the F-sharp interactive window over here. Okay, this is a read eval print loop, similar to what you might know in Python or Scheme. They've been around for a long time. F-sharp supports one of these. I can just type code in here if I like so, and I can see them evaluated. All right. Now I can also come from the editor, right-click, and say execute in interactive. All right. I'm going to do this once from the right-click menu. After this, I'm just going to press Alt-Enter. All right. And so, lo and behold, we have the correct result. We're done. Except, well, we're almost done because this is not the elegant code that I referred to, that I promised you guys. This is not great at all, right? And so let's do a little bit of refactoring. I want to see how simple and elegant we can make this. All right. The first thing I'd like to do is let's start getting rid of these list methods and kind of pulling them off into other functions that better describe what they're doing. Okay. So the first one is trivial. We'll just declare a name, sum, that is bound to the function list.sum. And then we can use it throughout here. And so we can just refactor and pull out these references to list. All right. And since we're refactoring, we always want to run our unit tests when we're done. Verify that we still get the correct results. Next, this guy's kind of an eyesore, isn't he? This lambda expression. So let's pull that out and put it into a kind of a top-level function with a good name. We'll call it square. And so I'm just going to cut that to the clipboard, write square in here, and then we'll come up here and declare it, square. And that works fine. This is not, this is totally a totally valid F-sharp function where I've bound a name to the thing on the right, which happens to be an anonymous function. There is a more succinct way to declare a function in F-sharp. And by, this is, again, they're essentially equivalent. It's almost syntactic sugar for this form. But I could declare the parameter here, and then I don't need the boilerplate around it. I can just have the expression. All right? And now that I've pulled this out, there's a place I can reuse it, right? There's another spot where I'm squaring things together. right? So right here is a square. So I'll go ahead and write square here of the sum, and I can delete that. Still getting the same result. Well, let's keep going. I said I wanted to get rid of all the kind of the list functions. So let's do something with this. What I'd like to do is declare a function called squares that performs mapping of square across a list. Okay? And so I'll just take this bit, write our function squares here, how that's going to be applied against the list. And then we'll declare a function. It's going to take a list, call list.map with square, and apply that against the list, okay? Whoops. And so we have the same result. And this looks pretty good now. What do you think? That's really getting to a statement of the problem. It's the square of the sum of 1 to 10 minus the sum of the squares of 1 to 10, right? And so this is perfectly fine to leave here. The only, you could make one minor change, which would be instead of having that computation be at the top level, instead put it inside another function and parameterize on the list so you don't have to name the list twice. That would be an option. But I'm here, my intention is to blow your minds. That's actually why I come to TechEd. It's very vain of me, I know. Got some smiles, okay. That's what I was looking for. I'm being facetious. And so I want to think more abstractly about this. We're going to take this probably further than you should go. All right, we're going to obfuscate this code perhaps a little bit, but I really want to give you a sense of the power of what you can do with F#. Okay, and just the power of functional programming in general. So let's think more abstractly about what we're doing here. We're taking a list. We're applying two functions to it, actually two sets of functions. First square and sum, and then sum and squares. And then we subtract the results. And if I think of that itself as a function, it's pretty simple to define. Okay? We can call it difference. And as parameters, it would take a function and a second function and a list. And it would apply the first function to the list and subtract from that the result of applying the second function to the list. Right? And when I hover over, I'll see that F# type inference has indeed figured this out. It's given me a generic method that takes A, it takes a function that goes from A to int, another function goes from A to int, and it takes a list of A and returns int. Okay, so it does figure all of that out for me amazingly. Now to use it here, we're going to have to get maybe a little more complicated at first. And so I apologize for that, but it's a stepping stone to further beauty. Okay? Further code beauty. So we're going to call difference. The problem is that I'm only passing one function into difference, and here I have two functions. I have square. I have square and sum, right? So in order to call both those functions, I'm going to have to wrap it in a single function, and I'll use the lambda expression to do that. All right. So I'm going to write a lambda expression. It's going to take a list. It's going to call square. Well, it's going to call sum with the list. Take that result, call square, and then return it. Okay? And then we're going to do the same thing here. We'll write a lambda expression that takes a list, calls squares with the list, applies squares against the list, takes the result, applies sum to that, and then returns the result. Okay? So a little bit more complicated, and at the very end, I can pass in my list. In fact, now that we're at this stage, I can move it up front, right, and pipe it in. Okay? So take 1 to 10, take the difference. And while this looks a little bit ugly, we're going to fix it in a second. But I just want to make sure, running my test again, it is the same. Okay. So how do we fix this? And again, it's looking back, taking a step back, and looking a little bit more generally at the problem, looking a little bit more abstractly. What is it that we're trying to do? We're applying two functions to a list. We apply the first function to the list, take the result, pass that to the second function, and then return that result. Okay? So conceptually, it's like this, right? Where I've got a function f and that takes x, a function g that takes x, and I'm calling f, passing x, taking the result, and returning it to g, passing it to g, and then returning the result. It's effectively like this. And we could create a function that wraps that, right? That kind of composes the two functions together, like so, where I could write a function f, takes x, passes x to f, takes the result, passes that to g, and returns that result. So we've effectively composed the two functions together. But in functional programming, functions are data. They are values, and they can be manipulated as such, just like numbers and other values in our source code. And so the notion of composing two functions together is something that's actually core and native to F#. There is syntax for this. And so I could write it instead like this, where I use this operator right here to compose F with G. And so what we're doing here is we're saying the same thing. H is a function that takes its single parameter that it got from F, passes it into F, that's composed with G, so the result gets passed into G, and then H returns the result of G. Okay? This one's a little mind-bending. It's okay if you didn't get it as the first time you saw it, but the result is beauty, because I can now get rid of these lambda expressions by composing square and sum, like so. Okay? And I can do the same thing over here by composing sum and squares. And let's make sure things run. And they do. Okay, now we're getting someplace that really starts to get into a simple statement of the problem. Take 1 to 10, get the difference of the square sum and the sum of squares. Right? Really getting to that core place. Now, I'll take it even a step further. One thing I really dislike about this is that difference is a function that I have to call all the way on the left. It would be really nice if it was just the subtraction operator or something that looked like it. And so we can define it that way as well. Instead of defining it with the name difference, let's create our own operator that if we squinted, it would sort of look like subtraction. I could, in fact, make it subtraction, but that would break subtraction for everybody else. So I don't want to do that. I want to break actual numeric subtraction. So we'll make it look like this, which one of my friends said looked like a Mars rover. Period minus period. And so now we can delete this and put it in between. And look at that. And so the core thing to take away from here, I mean, obviously I went too far, right? It was perfectly fine before. But I wanted to demonstrate the power of what you can do. That instead of, just stopping, instead I ended up creating a little DSL to solve my problem. Very easily, in just a little bit of code, I created kind of a little DSL that is specific to this problem that solved it. Is that cool? Yeah, some nods? Excellent. All right. So let's flip back. Using the best tool for the job. So I mentioned this earlier. This is something, again, I find it's very important to me. And it's something that I think this is a place where F# really needs to get some, and will gain some traction. That in a large application, sometimes we're bending over backwards and writing contrived code to try and map a language like C# or Visual Basic to a problem domain, a problem space that F# or another language really excels at, right? And so I'm a big advocate for using the right language for the right job. And so I'm an advocate for, if you have a low layer where you're doing data transformation, where you're doing business logic, that's a great place to use F#, right? If you're doing analysis and computation, that's a great place to use F#. If you're writing UI, you can write it in F#. But there are other languages that are better suited for that. I mean, a lot of the UI frameworks are object-oriented. So you could use that F# to do that, but it's functional first, right? Why not use an object-oriented first language to write that sort of code? And so I have a demo of this, and of an application. And I hope it's fun for you guys. This is a new demo. I hope it's fun. I hope you guys like it. But it is an application in which the core is written in F#, the UI front end is written in C#, and the unit tests are all written in VB, which is my favorite unit testing language for any language at all. Visual Basic is a great unit testing language. And so this is a Z machine. Has anyone here heard of a Z machine? Great. Has anyone here ever played a text adventure game where you say, go north, pick up the sword, kill the troll with the sword? Okay, yeah, I'm seeing some recognition. Who has heard of Zork, the game Zork? Yeah, okay, same people, right? The Z machine is a virtual machine for running text adventure games. It was actually developed in the early 80s by a company called Infocom. Infocom was a producer of a lot of text adventure games, including the beloved Hitchhiker's Guide to the Galaxy, maddeningly hard game. And at that time, there were a lot of systems to build games for. It wasn't like today, where if you're a console builder, you got to build it for like Xbox, PS3, and whatever Sony's got, whatever Nintendo's got, whatever Microsoft's got, right? You got 3. If you want to build it for a computer, well, maybe there's 3, right? Maybe there's Linux and PC and Mac. If you just want to cover everybody. Back then was a different story, right? If you wanted to write a game that hit the most people, the most consumers, you needed, the PC was there, but it wasn't necessarily the most popular, right? There was also Tandy, there was Apple II, there was the Mac itself, the early Macs, the Atari ST, there was the Amiga, the Commodore 64 and 128, right? You had to write the game a lot if you wanted to hit a lot of people. And a lot of those systems were very popular, equally popular in a lot of cases. And so Infocom's solution to this was to write the game once, and similar to what you would do with a Java program today, and make it cross-platform, write VMs for the different platforms. Now, I can't prove this, I couldn't verify, but I do believe that Infocom produced the first commercially available virtual machine, effectively. And so to write a virtual machine, to write a Z machine, you're writing an interpreter. There's a cool little instruction set, this very minimal instruction set. The game itself is just a byte array of the initial game memory. And so you have a program counter and a simple stack and local variables and that sort of thing, some registers. And you go through and you interpret each instruction. It's very fun to write one of these because at the end, you get to play Zork, right? So it's this exercise. Now, I took it a step further. I'm actually a little bizarre. I'm a super nerdy guy, and apparently I have more spare time than I should. And so instead of writing an interpreter, I wrote a compiler. And that's the demo I'm going to show. Because I just really wanted my games to run really, really, really fast. And so what the compiler does is it takes those Z code instructions from the Z machine, from the in-game memory, finds the ends of the routines, and then transforms them into an abstract syntax tree, and then performs data transformations right on those trees. So it's going to go through and do various lowering phases and optimization phases. And at the end, get it all the way lowered down to IL. Right? And what language is great for doing data transformation but F#, right? If you really think about it, a compiler is a pure function. It is something that takes one set of inputs and always returns the same outputs, right? It's, in a way, and so F# lends itself very well to running this application. So I kind of think of this as this is one of my data-rich applications. It's a compiler. But again, I'm using the best tool for the job. I'm using F# for the data transformation core of the system. There's a front end to it that's written in WPF. And I wrote a C# model view model application as that front end with a custom WPF text rendering engine in order to display all the text and wrap it nicely and everything. And then the unit tests are written in VB. So let's take a look at this. I hope you guys like this. So here is my solution. And the key thing I want to point out here is that when you write F# code in Visual Studio, in Visual F#, you get all of the usual suspects. There is a project system. There is debugger support. Everything is there. I was able to run the Visual Studio profiling tools on it and get analysis when I found I needed to find the hot paths and speed things up. Okay, so you get the full power of Visual Studio to write F# code. Okay, and I just want to make that very clear. You do not have to write F# code in Vim or Emacs or Notepad or anything. You can write it in Visual Studio and get full support. And so the application, whoops, wrong computer. The application is, again, here's my C# application, here's my F# core, and down here are the VB unit tests. So I get all 3 colors of purple, green, and blue in my Solution Explorer, which makes me happy. It's like a fruit salad. Okay? And so the F#, I want to kind of give some indication of why I used F#. So F#, these are the places where I define my data types. Okay? And the abstract syntax tree has expressions and statements. Okay? Some of them are very simple, like constant expressions or temporary variable expressions, reading a local or reading a global from the machine. Okay? And then statements likewise. There are some rather simple ones. And then in order to construct my trees, I wrote combinators. Similar to what we just did for Project Euler, I wrote a little DSL that let me construct trees. Okay? So an example right here is how I would construct a binary expression that performs addition. Okay? it takes a left and a right, which in fact is two expressions, okay? And then it constructs a binary operator with the kind add, okay? And so I can use this little dot plus dot in my binding logic in the compiler when I decide what I'm going to do with the add instruction. So here's where the add instruction comes in, where I'm going to do pattern matching, an F# functional feature to figure out, okay, which instruction am I looking at that I've parsed out of the Z code. And so it takes the operands left and right, which come into me as expressions. Okay, I can hover over and see those are expressions. It uses one of my little functions, toInt16. All that does is it wraps that expression in another expression, because all addition is signed in the Z machine. So it wraps it in a conversion expression, which will convert the int expression to a signed int16. So it does that for both the left and the right. Then I use my add operator, and I call store. And so I can write all of the Z code functions like this, or all of the opcodes, the instructions that appear with these little combinators. So I've written this DSL to solve my problem. And this, as I've written this, has helped me find bugs. You know, where the F# compiler has simply squiggled and said, no, that doesn't line up, right, as I've defined it. Okay. Well, let's actually run it, because I'm certain that's the exciting part. So we're going to load. Actually, the first thing I want to load, this is not really a game. It's a test game that somebody wrote to verify interpreters. And so I can run that, and you can see it runs all the way to the end, and all the tests passed in it. So I know that my interpreter is interpreting. It's not an interpreter, it's a compiler, but it is correct, at least as far as this game says they are. Now, what you really want to see, though, is Zork, right? And so I can run Zork. Now, my compiler is a JIT compiler. So when it encounters a routine for the first time, it's then going to go ahead and compile it. It also has a regit step, where if it's executed more, it reads some certain heuristic, like it's of a certain size, and it's executed more than 10 times, it will also then recompile that function optimized, because optimization takes more time, right? And so the game is playable. I can, this is the beginning of the game. I can open the mailbox, I can get the leaflet, and I can see the initial in-game advertisement, okay? But cooler yet, we could just run the game from the top. All right, I've got a script here. We'll reset it and just watch it go. This actually runs in about a second, but updating the UI takes much longer. And so that's where most of the time is. But we hit Master Adventurer, and we're told to go play Zork 2. Okay, so is that, oh, I'm sorry, was that not applause-worthy? We just ran Zork all the way to the end with a perfect score. Thank you. I worked on this for a long time, guys. I've also built into this, this is now almost self-indulgent, things like a profiler, so that I can see the routines as they compile and which ones get optimized and all of that, and what the difference in the IL byte size. But the cool thing about this is that compiler, that whole thing is written in F#, using that tool that's appropriate for the job of writing this big data transformation of going from Z code to IL. All right. Okay. So let's get to the third and final part of this talk, and that's information-rich programming. This is where we're going to start talking about some of the F# 3.0 functionality. This is where it starts getting into a bit of the talk that might be more for people that are professionally using F# today and maybe haven't dabbled into F# 3.0 yet. But this is a feature, the features we're going to talk about really target a very specific problem. And this is something we like to call information-rich programming. So I have two propositions for you to explain what this means. I don't think either of them are controversial. So the first is that we live in an information society. How many people believe that? If you don't believe that, log onto your Twitter account, or check out Facebook, or see how targeted Amazon and other companies are getting at selling things to you, right, because of all of the information that is out there today. All right, I think that's pretty uncontroversial. The other proposition is that our languages, however, are information sparse. That's by design. These are general purpose programming languages, right? They're not meant to have Facebook encoded directly in them. I do not need to know have my language know about my friends and my friends' relationships and whether those relationships are complicated or not, right? That seems somewhat inappropriate for a language. But in reality, this is a problem. This is actually a big problem. Because, well, there's challenges here, right? So the reason this is a problem is because the information that is out there, there's an impedance mismatch with that information and our statically typed languages. Often the information itself, the data, if we get it back from the web, for example, is often pretty dynamic. Or it has rich type definitions that our languages don't understand, right? And so there's no mapping to that. So what's the solution? You add a service reference to your application, you generate some source code, and you now get your statically typed language to be able to talk to that. You do some data contracts, whatever, you do some entities. Doesn't matter. You just make it so that your static type, you have something in between to allow your statically typed language to be able to talk to that data source. And that's a problem in itself, right? Because now you need to integrate that code generation tool with the build process, with source control. You need to remember to run it, right? The schema changed. I forgot to run the the code generation tool, and now my application broke at runtime when I deployed it to customers or whatever, right? Hopefully you had a staging environment. And then there's no elegant way, as I just said, to handle schema change, right? You have to rerun the the code generation tool. Instead of seeing things at build time or design time, seeing where schema change would happen. This is a real problem as well. You have a loss of type information often, where you have to upcast, for example, to object. Maybe because the schema might define a field or a piece of data as being maybe an int or maybe a string, right? And so you don't really have a way that you can map it directly to your language. And so you have to use object, or if you're at C#, you can use dynamic or VB to use late binding. Or even you just have to parse the string that comes back and say, was it an int or was it text or whatever, right? Plus, what's really critical here and why this is really frustrating is that our languages should make your experience better. These data sources often have rich schemas and rich data definitions, and our statically typed languages should take advantage of that and make your experience better, not worse. Okay? And so for F# 3.0, we introduced a feature that's called type providers. And here's why that matters, all right? To deal with this problem, these challenges, this is why it matters. First, programming the web today. This is what the proliferation of web APIs looks like. You can see all the way on the left, there's eBay. But starting in 2007, it effectively doubled by the amount that it added of web APIs. It was 600 between 2007 and 2008. Then, actually, between 2008 and 2009, there was 500, then 1,000 between 2009 and 2010, 2,000 more up to 2011. This is an old chart. It's 2 years old, right? And what's also interesting is that the sorts of companies that we're seeing open up with web APIs and data for consumption in your applications are becoming things that are companies just like American Express, right? Or MasterCard. Really, everybody's getting on the bandwagon of having web APIs available. And this is a problem for you because when you want to go and absorb some new data source in your application, you now have to go and learn how to code against a new API. And that makes it harder for you to get your job done, right? And so I mentioned that's why we introduced F# type providers. I like to call it IntelliSense for data. That kind of sells the feature short a little bit because it's much more than just IntelliSense. Design time experience is very critical for the end-to-end experience of type providers, but it is also a compile time step, a build time step, that's also very critical to this experience. So F# type providers, 3.0 type providers, this is kind of their selling points. First of all, they provide an integrated solution across any data set, any data source, right? So you wind up with a unified programming model for any API, okay? The programmer gets to stay focused on their code as opposed to having to go write data contracts and figure out how to parse the data out of the queries and the JSON that comes back and whatever. The fourth one down here is a biggie. It's kind of fourth on the list, but it's really a big thing. Being able to access web-scale data sources. Today, the web data sources, the schema for these web data sources, some of these schemas are actually just completely inconvenient to generate source code for. Either they're too large, too vast to be generating source code, or it's something you can't even download, it's just so large. Or it's something that's dynamic, completely dynamic, that might be changing out from under you, right? And so where a dynamic application, a dynamic language like JavaScript can react to it much easier, it's much harder when you're generating source code against it, right? And then the last point is that schema change integrates with the IDE and the build system. Okay. So we're going to look at this with Freebase. Freebase is a web-edited, nerd-edited database. I say nerd-edited because as we start looking at the sorts of things that wind up in Freebase, it seems these are the sorts of things that nerds like myself might be interested in. Okay. There are 40 million topics in this database, 40 million entities, really. It's ridiculous how big this thing is. It would be completely inconvenient to try and download it, and then it's changing all the time, right? It's always getting new things added to it, and so it's not even convenient to be up to date. So here's an example of the code you'd have to write in order to access Freebase in F#. Again, you have to declare your data contracts right down there. And then all this code to actually perform the query, get back the data, the JSON back, construct it into something that's meaningful, right? And then this is just to take all the chemical elements and kind of print out their boiling points and their atomic mass, right? This is the code you would need to do that. I will remove it because I feel you're reading it. And that disturbs me because that code is disturbing, right? We shouldn't have to write that sort of code. And I'll give you an alternative. All right. So, looking at Freebase, I have a different F# script up here. And we're going to use an F# type provider for Freebase. This type provider, I actually just went and grabbed via NuGet. So I went out to NuGet and I said, give me a type provider for, say, F# Freebase, right? And I found F#.data, and it has a type provider for Freebase. I could also come in here and give you an example of the sorts of things you can find type providers on. And there's all sorts of things that are out there already that provide type providers for different things, right? So there's a type provider for XAML, right? So I could dot through a XAML file, and it would dynamically introduce types into the type checker from my XAML file, right? So there's pretty cool stuff here, and it's readily available to you for exploring. So I grabbed that package, the F#data, and I've added a reference to it. I've got an API key that I got from Google Code so that I could ask more requests in here, and it wouldn't just stop responding to us while we demo. But I'm not going to give you my API key; it's hidden away. And then here I declare I get a data context for this F# data provider. Okay, and now I can access Freebase with IntelliSense. So with the power of dot, so I'm going to type data dot, and I'm into Freebase. Okay, it's gone down. It's grabbed the piece of the schema that it needs to show me the next level. All right, and so I was poking around here the other day, and I was looking for things to look at, and I was happening through the society, and so I found, oh, here's celebrities, right? And I'm thinking, well, what are the sorts of things that, as I like to say, maybe it's a little facetious, but I like to say nerd-edited database like Freebase. What is it that the sorts of folks editing Freebase would be interested in about celebrities? And so I'm thinking, well, maybe it's the movies they've been in, the recordings that they've made recently. And so I dot in, and I find that's not the case at all, right? It turns out that they care about abused substances and rehab facilities that they've attended. And I looked at the very bottom, and I see this thing that says super couples, right? And I'm thinking to myself, what's a super couple, right? I don't know anything about celebrities, right? You go to the dentist office or the doctor's office, there's those magazines sitting there on the table. I've never read them, as far as you know. So I don't really know anything, but I'm interested in super couples. So I select it, and the tooltip tells me what they are, right? It's teaching me about popular culture. A celebrity super couple, also known as a power couple or dynamic duo, is a popular or financially wealthy pairing that captivates and intrigues its observers beyond normal expectations. Wow, that's ridiculous, right? So, I have to see what it is So I'm going to go ahead and pipe that into a grid. I've got this extra script up here that'll present it for me in a WPF grid. I just run it with Alt-Enter, and sure enough, here are the supercouples. And now I see what this is about. Here's Ike and Tina Turner and Tomcat. There's Brangelina. All right, so now I know what a supercouple is. Okay, funny. Ha ha, Dustin. Let's go to something a little bit more nearer and dearer to my extra geeky heart. All right, and so instead of going there, let's go to arts and entertainment. I actually have a music degree, so this is interesting to me. Right? But then when I get in here, I see this very tantalizing fictional universes. And at this point, I see what the people editing Freebase are actually interested in and how much effort they're willing to put in here. This is ridiculous. IntelliSense is telling me, welcome. Welcome to the fictional universe domain. You are in a friendly place. Okay, so we'll select that. And you can see again how much data is here. This is it's just kind of ridiculous, right? We have fictional objects and the destruction of those objects and who destroyed them and all of this. It's a vast amount of information. And so to kind of get a sense of this, let's do it again. Let's take that fictional universes and let's pipe that into ShowGrid and just evaluate. And okay, I see some of my favorites. I see the Buffyverse. I see the Hooniverse. So those are things that are, reasonably popular. But then I start seeing things I have never even heard of before. I mean, a lot of them I have, and I'm a pretty nerdy guy. And there's stuff up here I've never ever heard of, right? So this is kind of the vastness of the information. But we're just kind of poking around and looking at data and kind of playing fun at Freebase and, the sorts of data that's up there. But what if I just really wanted to solve a problem, right? So let's take this fictional universe data and let's find out who the most popular fictional universe creator is. Right? Let's take that data, perform a query, and get a meaningful answer out of it. Right? And so I've got some code down here. And that's what that does. First, it goes, again, dots into fictional universe, gets the universe creators, and then it maps over that. Right? Maps over that with a transformation function. For each creator, it creates this creator data type that's up here with the name, with an image, and then the number of works. And to get the number of works, it performs another query on that data, where it looks at the creator, says, give me the fictional universes created, and then collect from there, all those fictional universes, all the number of works that are actually set there. So these don't actually have to be works that that particular creator wrote. Anybody could have written them, but written for that universe. So we're just going to find out who's the most popular, who's made the fictional universe that the most works have been set in. Okay? And then we take the length and we set that to works. And then finally, we just call ShowGrid. And right away, that was fast. We see some familiar names. I'm going to take a poll, though. Who's got a guess as who the most popular one, according to Freebase, will be? The most popular fictional universe creator. Any ideas? What's that? No. Gene Roddenberry's a good guess. Because William Shatner alone has ghost-written maybe 200 works in Gene Roddenberry's universe. Anyone else? Any other guesses? Let's see. I'll just go ahead and sort by the number of works. George Lucas. Now, of course, the data set's not complete. There are far more than 171 works set in the Star Wars universe, clearly. But it's the idea that, yes, we're working against Freebase. But suppose I was working against a different database and trying to collect information, customer data, and perform some sort of analysis upon that, right? Find the number of people that are located around a certain area, for example, correlating it with geographical data. This is the sort of thing you can do with F# type providers in your applications. And then also, as part of F# 3.0, kind of the other side of type providers, the idea of if type providers give you the data, you need to have a way to query it. Now, F# always had this way to query it, but we introduced kind of a link-like syntax into F# 3.0 so that you could write it in kind of a more link style. And so this really does the same thing that we just saw, but it has query operators instead of calling seek.map and seek.collect and those sorts of things. And so we have things like sum by on that. And it's just going to produce effectively the same results. Okay? So that's Freebase, and that's F# type providers. All right. So that's actually the end. We have just a handful of minutes, about 8 minutes left. And I want to take the opportunity to answer some questions. So I would like to say thank you for coming in here at 5 o'clock, for sitting up close like I asked, and for listening. Try fsharp.org. If you're interested in exploring F# and you just want to get your feet wet and see what the capabilities are, that's a great place to go. There are F# resources at fsharp.net, and the F# Software Foundation is also a very interesting place where you can find testimonials and resources about who is using F# and in what sorts of applications and all sorts of utilities as well. So that's at fsharp.org. This is my email address, dustin.campbell@microsoft.com. My Twitter handle is dcampbell. And so if you want to get in touch with me, you can do so like that. All right? So I'm going to flip past this, and I'm going to go ahead. What is all this? I don't know what they put in these decks anymore. This is the important one, the QR code. So please leave an evaluation. It does help me get to continue to do talks here. But at that point, let me just ask, are there any questions? Yeah. And I'll just walk up to you, and you can ask me.
So you talked about that in the type languages, we have to generate code.
Mm-hmm.
But basically, what you just showed us, the Freebase just generated some code for us, right? That schema doesn't change that often. But again, if it does change, we have to get the new one, the new schema as well.
Okay, so the question was, I talked about how in order to solve this problem of the impedance mismatch with statically typed languages, we generate source code today. And what I just showed was Freebase generating code effectively. And how don't we have to download that schema again? So what you just saw was I did not, and maybe I may not have made it very clear, it did not generate source code. It introduced types based on the schema into the type system, okay, that were introduced at design time and then also at build time. And so if you want to break, if the schema does change, you will observe that through a compile, because it will go and refetch the pieces of the schema it needs again. So if you have like a continuous integration system and you see that Freebase changes its schema in some radical way that breaks your application, you'll see that happen in your continuous integration system. So you don't have to go and know that it's changed and go regenerate. It'll go and dynamically do that at build time. And that's one of the major benefits of this system. If it changes when your application is in deployment at runtime, there's nothing that solves that yet. That is not a solved problem. Something that is on the back of everybody's minds. But this makes that step of getting schema change into your application at design time and at build time seamless. Okay? Any other questions? Yes, sir. How is Microsoft using F#? Is it used a lot inside Microsoft? It's been used for several research projects. It's been used for some data analysis pieces, and so for some kind of technical computing sorts of really where it is really very well suited. I remember there was a study recently, there's some work to analyze Xbox Live data, and that was all written in F#. My colleague who's here with me, for example, is another person I know that used F# to when he was working at Microsoft Robotics, right? And he wrote F# code to control robots, and so it does get used. It's not the major language that we use inside Microsoft. It's still very much C++ and C#, and those languages very much dominate. But F# has a kind of a core niche of functionality that's really good suited for it, and that it is used inside Microsoft for some of those things. Any other questions? All right. Well, I think we can call it done then. Thank you very much for your time, guys.